Okay, good morning. Welcome to
FunMath number 203.
FunMath number 203. So today we were working on the 2004 AMC8, and they asked, kind of a straightforward counting problem. So we're going to do one that's just slightly more complicated. Okay.
Yep.
How many ways can you select 3 people from a group of 5 if order doesn't matter? So they were asking 3 people from a group of 4,
Which is pretty easy.
which wasn't too hard. But so how many ways can you select 3 people from a group of 5 if order doesn't matter?
So we have 5 people, A, B, C, D, and D.
Okay.
We could do,
We're going to try to find groups of 3. Okay, so before you just jump into it, what's a good way to even think about this?
well, we can start with all the ones that start with A.
Okay, so start with all the ones that start with A. Or where A is the lowest letter alphabetically. Okay? Now what do you have to do next? If you know A is in there, what do you have to do next?
We have to choose 2 out of 4.
We have to choose 2 out of 4 now.
So we can do BC. We can do BC, BD, and BE.
Okay.
CD and CE.
BC, BD, and BE. Okay, so keeping it alphabetical, it actually helps us organize this. Okay, what would you do next?
Then I do CD and CE.
CD and CE. So all of these have A in them. A, B, C, A, B, D. I'm just not writing the A.
And then A, D, E.
A, D. Okay, so that's interesting. So how many have A as their lowest?
6 of them.
6 of them. That's interesting. Okay, what's next?
Now all the ones that have B as their lowest letter,
Okay.
but we can't use A.
We're not going to use A, okay? Because we've chosen A to be the lowest letter already. Now we're looking at ones where B is the lowest letter. So what problem are we trying to solve now?
We need to take 2 from 3.
We need to take 2 from
So we
3.
can do CD and CE
CD, CE,
or DE.
DE. Okay.
And then we can start with C as our lowest letter.
Okay, next we'll do C as the lowest letter.
Then it would be just C, D, E.
C, D, E. Okay, so how many are there?
There's 6 plus, there's 10.
Okay, so it looks like we found 10.
Because the ones with D don't work, because there's not enough letters.
The ones with D as the lowest letter don't
Yeah.
work.
Because
Okay,
there's not enough letters.
let me show you something really interesting now. Maybe I should write the B's. And we see there's 6 that have A in them. How many have B in them?
Exactly half. There's 3 that have B in them.
That's
No.
not right.
No, a lot. There's 6 that have B, and actually,
There's 6 that have A, 6 that have B. How many have C? See if you can count that. Circle the C's.
C. Am I missing one?
6 that have C. How many do you think have D?
Probably 6.
All right, try.
1, 2, 3, 4, 5, 6.
And how many do you think have E?
E. 6. 1, 2, 3, 4, 5, 6.
Okay, so in these counting problems, there's a lot of symmetry. The same number, this is one way you can check if you've counted everything. If you have counted everything properly in a problem like this, there should be this sort of symmetry where A is in the same number as B. Do you know why that should be the case?
Because order doesn't matter.
Yeah, there's no real difference between A and B if they're on a team, right?
Yeah.
So the teams that have A should be the same number as the teams that have B, unless there's some difference between them. But there's no difference between these, right?
Yeah.
Okay. All right. Very good. Very good, sweetie. You okay?
Yeah.
Did you get bit by a mosquito or something?
No, just a little scratch.
Okay. Good job. This is these are problems from these counting problems are from a section of math called combinatorics. It's a really neat subject, actually. You'd be amazed at how many cool things you can do in combinatorics.